Rectilinear motion. Rectilinear motion is just one-dimensional motion, and the point of this is to understand the relationship between the position, the velocity, and the acceleration. So we're going to write down a variable for each. Position, let's go with x. So we've got x indicates the position, v indicates the velocity, and a indicates the acceleration. Now these three are related based upon the time. So the velocity, the average velocity, is going to be the change in position, so I'll write that with a delta, divided by the change in the time. So the position varies as a function of time, and as that moves along, that indicates the velocity. So now we've got the acceleration, and we can write that as the change in velocity divided by a change in time. Now these indicate average velocities and average accelerations, and so we can get the instantaneous velocity by changing this to a derivative. And the instantaneous acceleration we can write this way. And of course that is the second derivative of the position with respect to time. So we're going to be looking at rectilinear motion, and all we need to know is the relationship between position, velocity, and acceleration. And here I've written these down. X is the position, so that's kind of the base variable. V is the velocity, and it's the first derivative of the position with respect to time. And A is the acceleration, which we can write as the second derivative of x with respect to time. Let's look at a simple example of rectilinear motion. So here's an equation of position versus time. And the question is, what is the velocity and what is the acceleration? So the position versus time is the position is equal to 6t squared minus t cubed. And we could graph this out. We could make some type of graph here and write down x versus t at t equals 0. This would start at 0, and as t increases, initially this will increase to some point when it'll begin to decrease when this t cubed term takes over, and it'll go further and further negative. So that's what the position versus time looks like. And we could just write down here velocity is going to equal the derivative of x, the position, with respect to time. And I can just do this from sight. That's going to be 12t minus 3t squared. So that's an expression for the velocity, and the acceleration is that second derivative of x with respect to time, which could also be written as the derivative of velocity with respect to time, which I can get right from here, and that would be 12 minus 6t. So there's our simple example. The position here is given as a function of time. The question is, what is the velocity and what is the acceleration? So we can get the velocity here just by taking this derivative. We get 12t minus 3t squared. So that's the velocity as a function of time. And the acceleration as a function of time is 12 minus 6t.